Algebra 1, Unit 2, Lesson 3, The Name Game, Retrieval Problems, Illustrative Mathematics, for problems 1, 2, and 3. We need to rewrite each expression using the rules of exponents. Number 1. b to the third power times b to the fifth power. To multiply b to the third power by b to the fifth power, you just add the exponents. Here's how it works. When you multiply powers of the same number or letter, like b, you keep the base, in this case b, the same, and add the exponents. So b to the third power times b to the fifth power equals b to the eighth power. This means you multiply the base, b, by itself 8 times. In other words, multiplying b to the third power by b to the fifth power is the same as b to the eighth power. Number 2. When you have something like this, it means you're raising n to the third power all to the fourth power. To solve this, you multiply the exponents together. Here's how it works step by step. N to the third power means n times n multiplied by itself 3 times. Raising that to the fourth power means multiplying n to the third power times n to the third power times n to the third power 4 times. Instead of writing all that out, there's a shortcut. Multiply the exponents, so n to the third power times the power of 4 equals n to the power of 12. This means n is multiplied by itself 12 times. Problem number 3, m to the fifth power over m to the eighth power. When you divide m to the fifth power by m to the eighth power, you subtract the exponents because the bases, the m, are the same. Here's how it works step by step. M to the fifth power means m times m times m times m times m, which is m multiplied by itself 5 times. M to the eighth power means m times 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 m, which is m multiplied by itself 8 times. When you divide, cancel out 5 of the m's from the top and bottom, which leaves 1 over m to the third power. So the answer is 1 over m to the third power, which means 1 over m multiplied by itself 3 times. Problem number 4. Find the missing terms of the geometric sequence. Let's figure out how to find the missing terms in the geometric sequence where x equals 1, 2, 3, 4, 5, 6, and g of x equals 128, then 4 unknown values, and 4. Step 1. Find the pattern or common ratio. In a geometric sequence, we multiply each term by the same number to get the next one. To find this number, called the common ratio, we can divide the last term by the first term. The first term is 128, and the last term is 4, so we do this. The common ratio is 4 over 128 equals 0.03125. This is a small number, but we don't need it exactly. We'll break the process into steps. Step 2. Check the steps between terms. We know the terms in this sequence are being multiplied by a constant number each time. Let's guess that the common ratio might be 0.5 because that's a common ratio. Let's check if this works. If each term is being multiplied by 0.5, we can fill in the missing terms like this. Start with the first term. G of 1 equals 128. Multiply by 0.5 to get the next term. G of 2 equals 128 times 0.5 equals 64. G of 3 equals 64 times 0.5 equals 32. G of 4 equals 32 times 0.5 equals 16. G of 5 equals 16 times 0.5 equals 8. And finally, G of 6 equals 8 times 0.5 equals 4. Step 3. Fill in the missing terms. The missing terms are G of 2 equals 64, G of 3 equals 32, G of 4 equals 16, and G of 5 equals 8. Here is the full sequence. G of x equals 128, 64, 32, 16, 8, and 4. Each term is half of the previous one. For problems 5 and 6, find the rate of change using the information given. Let's look at the table for number 5. To find the rate of change using the table, you compare how much f of x, the output, changes when x, the input, changes. This is similar to finding the slope of a straight line. Step 1. Use the formula for rate of change. The rate of change between 2 points is found using this formula. Rate of change equals the change in f of x over the change in x. This means you subtract the two f of x values and divide by the difference in the two x values. Step 2. Choose 2 points from the table. Let's choose 2 points from the table to calculate the rate of change. When x is 3, the value for f of x is -5. When x is 5, the value for f of x is -1. Now we need to find the difference in the f of x values. To find how much the f of x values changed, subtract the earlier value, -5, from the later value, -1. Take the -1 and subtract -5 from it. Subtracting a negative is like adding, so this becomes -1 plus 5, which equals 4. This means the f of x value increased by 4. Next, find the difference in the x values. To see how much the x values changed, subtract the earlier value, 3, from the later value, 5. Take 5 and subtract 3 from it. The result is 2. This means the x value increased by 2, so the difference in the f of x values is 4, and the difference in the x values is 2. Next, we can use these differences to find the rate of change. Step 3. Calculate the rate of change. Now divide the change in f of x by the change in x. The rate of change is 4 over 2, and 4 over 2 equals 2. Step 4. Repeat for other intervals. You can do the same for the other intervals. From x equals 5 to x equals 8, the change in f of x is 5 minus -1, which is the same as 5 plus 1, and that equals 6, and the change in x is 8 minus 5, which equals 3. So the rate of change is 6 over 3, which equals 2. From x equals 8 to x equals 12, the change in f of x is 13 minus 5, which equals 8, and the change in x is 12 minus 8, which equals 4. So the rate of change is 8 over 4, which equals 2. So the rate of change between any 2 points in this table is 2. This means for every increase of 1 in for the x value, the f of x value increases by 2. Finally, number 6. Let's find the rate of change using the points -12, 7 and -6, 31. The rate of change tells us how much the second value, called y, changes as the first value, called x, changes. Step 1. Find the change in the y values. Look at the y values. The first point has a y value of 7, and the second point has a y value of 31. To find how much the y values changed, subtract the first y value from the second y value. Start with 31 and subtract 7 from it. The difference is 24, so the y value increased by 24. Step 2. Find the change in the x values. Next, look at the x values. The first point has an x value of -12, and the second point has an x value of -6. To find how much the x values changed, subtract the first x value from the second x value. Start with -6 and subtract -12 from it. Subtracting a negative is like adding, so this becomes -6 plus 12, which equals 6. So the x value increased by 6. Step 3. Find the rate of change. Now divide the change in the y values by the change in the x values. In other words, how much did the y value change for each 1 unit of x value? Divide the change in y value, 24, by the change in x value, 6. The result is 4. So the rate of change is 4. This means that for every 1 unit the x value increases, the y value increases by 4. Thanks for watching, and I'll see you in the next video.